first question is establish the mathematical relationship between flow and speed for the given characteristics. So from here, when it is a relationship between flow and speed, we will use the Q to U. That way, the formula that we will use is Q equals to jam density times by speed minus by jam density over free flow speed times by speed square. So from the data we got, the free flow speed is 90 km per hour and the jam density is 112 vehicles per kilometer. And this is the mathematical relationship between flow and speed. Then, for the next question, estimate average speed and density when flow is at maximum theoretical flow. So the formula for maximum theoretical flow is Qm equals to free flow speed times by jam density over 4. So this is a simplified version. It would usually be UF over 2 times with kg over 2. So we get here. And then we have the value for UF and kj and we sub it in. So we get 2,520 vehicles per hour per lane. From this value that we get, we will sub into this equation, into this Q, alright, that we found in the first question. And then we will get 2,520 equals to this. So by using polynomials equation, we can solve this. We can key in the calculator and we will get speed equals to 45 km per hour. To find density, since flow equals to speed times by density, we just rearrange it and we will get K equals to Q over U by using the maximum theoretical flow that we found, that we calculated. So we would get a density of 56 vehicles per kilometer. So for the part C, estimate the maximum theoretical flow and why it is different from the observed volume. By using the formula of maximum theoretical flow, we would get a total of 2,520 vehicles per hour per lane theoretically. But what we got from the data, the observed max flow is 2,000 vehicles. The difference between these two might be due to the presence of human error, such as error in recording the data, or maybe they miscalculated the number of cars that passed by. There could be a big possibility that they did not use the sensor line, but instead they relied on human eye observation. Hence to why this type of difference might occur. Thank you very much. Okay, for the last part, section D, estimate the average speed of vehicle if traffic flow is 1,000 vehicles per hour. By using the formula we got from the relationship of QU, subbing in 1,000 vehicles per hour into the Q, and then rearranging this formula, we would get this equation. From this equation, we can solve it by using our calculator, and we will produce the speed is equivalent to 80 km per hour for every 1,000 vehicles per hour. This is the average speed. Thank you very much.
Hello, for next, question number 4. A study of freeway flow at a particular site has resulted in a calibrated speed-density relationship as follows. And from this relationship, we need to determine the free flow speed, the jam density, the maximum flow, and also the density when flow is at the quarter of the maximum flow. We are also needed to sketch the flow density relationship and show all the relevant data on the diagram. From the equation given in the question, we can also rewrite the equation as U equals to 100 minus 0.9k. So for question A, the free flow speed, based on the UK relationship U equals to UF minus UF over kj times k, we can find out that the value of UF is equals to 100 km per hour. And then for the next question, for jam density, we can find out from the equation that UF over kj is equals to 0.9k, which means that UF over kj is equals to 0.9, and we have found that UF is equals to 100. So we just put it into the equation, and then we can find out that the value of kj equals to 111 vehicle per kilometer. Next, for question C, we can find the maximum flow by using the QK relationship, where the Q equals to KUF minus UF over kj times k square. First, we need to find the value of KC, which is equals to KJ over 2, and we find out the value is equals to 55 vehicle per kilometer. And then to find out the value of QC, we just plug in the value of KC into the QK equation, and we find out the value of QC equals to 2777 vehicle per hour. Next, for question D, we need to find out the density when flow is at quarter of the maximum flow. So we need to find out the flow first, which is equals to 694 vehicle per hour, and then we put it into the QK relationship equation, and we find out the value of K, and then we get the value of K equals to K1 and K2, 7 vehicle per kilometer and 103 vehicle per kilometer. And finally, this is the flow density relationship, which is also the QK relationship diagram, and all of the value is find out and put on the diagram.
Hello, I'll be doing question 6. The question stated that while taking measurement by moving observer method, a test vehicle covered a 1 kilometer section in 1.5 minutes going against the traffic and 2.5 minutes going with the traffic. Given the traffic flow was 800 vehicles per hour and that test vehicle passed 10 more vehicles than passed it when going with the traffic, then we need to find these 4 questions, which we will do A first, which is the number of vehicles encountered by the test vehicle while moving against the traffic. Okay. For this question, we use this image to make us easier to understand how the test is proceed. Okay, here we got the test vehicle, which starting point is point X, then going to point Y, and from the question, the total length is 1 kilometer. Then after reaching point Y, it will turn around and use the other side of the lane to go back to point X again. For the first phase, which is from X to Y, we call it the traffic lane. And from point Y to X, we call it against the traffic lane. Okay, then we got an equation to calculate the flow, the volume of vehicle, which translated to Q is equal to open bracket X is plus Y1 is minus Y2 is close bracket divided by open bracket TA plus TW close bracket. Okay, now we need to know what this unknown mean for. Okay, for Y1 is it is the number of vehicle that overtook you during when your test vehicle is on the traffic side, traffic lane, which meaning when we on this part of the lane, we count how many car or vehicle that overtook us during this phase. And okay, and after that we got Y2 is, which the number of vehicle that we overtook during the traffic phase, during the vehicle traffic phase, meaning the number of vehicle that we overtaken when we're in this part of the lane. Okay, then TW is the time taken for the test vehicle to go through full length of this road, which in our case is 1 kilometer. And then we got X is the number of vehicle that you encountered while going against the traffic, meaning when you're turning around and you are at the bottom part of this lane of this road, we count the number of how many vehicles that we pass through here at this traffic lane. And TA is same like TW, but for the against the traffic time taken for the full length, to travel the full length. And Q is the volume of the traffic, which the question already give us. Okay, then we just need to plug in this value. We have this Q is value, which is equal to 800 vehicle per hour. Then X is unknown that are asked from the question A. Then we get Y1 is minus Y2 is, which is not given directly in the question, but since this part of sentence of this one sentence of the question that say the test vehicle passed 10 more vehicle than passed it when going with the traffic, meaning when we at this pace we have we took overtaken 10 more than other vehicle overtake us, meaning Y2 is always 10 more than y1 is. So we can do this, can conclude that y2 is negative 10, then y1 is 0, so to make it easier. Then for the time, we just convert it into minute, into hour. Then we get this answer, which is 63.33 vehicle. Okay, for question B, it asks for the speed of the traffic being measured. Okay. For this question, we have an equation which is equal to T is equal to TW minus open bracket y1 is minus y2 is close bracket divided by Q is, which is the volume. We have all these number already with all the values, so we just need to plug in into more hour, and yes, we got the T is. So for the speed, we need to have the length divided by the T is. T is for the traffic, the time traffic. Then we know that the length is 1 kilometer. Then we divided by the answer from the previous equation. Then we get the speed. The traffic speed is 18.46 kilometer per hour. Okay. Then for question C, the density of the traffic stream. Okay, we know that the relationship between the volume, speed and density is equal to volume equal to speed time density. So we have the volume and we have the traffic speed, which is we recently get from question B. Then we can calculate the density, which is equal to 43.34 vehicle per kilometer. And lastly, for for question D, it asks whether the test vehicle was traveling faster or slower than the traffic stream on the traffic set of the road. So the traffic speed we already get from question B, which is equal to 18.46 km per hour. Then we need to calculate the vehicle speed. So to calculate the vehicle speed, we need to divide the distance traveled divided by the time vehicle took to travel the whole distance. So in this case, we travel for 1 kilometer at 2.5 minutes. So we just need to convert the 2.5 minutes into an hour, Then we divided it to the length. Then we can get 24 km per hour for the vehicle speed, which means the vehicle speed is more than the traffic speed. So we can say that the test vehicle travel faster than the traffic stream. Okay, that is all from me. Thank you.
Last but not least, question number 8. In a road section, when the traffic flow is 1,400 vehicles per hour, the average speed is 20 km per hour. And when the flow is 1,300 vehicles per hour, the average speed increased to 35 km per hour. If the relationship between U and K is linear, we can estimate the traffic density, the maximum flow, and the average speed. To estimate the traffic density, we can use the Q equals to UK equation. By substituting the data from the question, we can find the value of K, which is 70 vehicles per kilometer and 37 vehicles per kilometer. Next, estimate the maximum flow. In order to find the maximum flow, we need to find the value of Kj and Uf. To find the value of Kj and Uf, we can use the equation from U and Q relationship, which is Q equals to U times Kj minus Kj over Uf U square. By using this equation, we can find the value of Kj and Uf, which is 114 vehicles per kilometer and 51.82 km per hour. When we already get the value of Kj and Uf, we can find the value of Qc, which is 1,477 vehicles per hour. Last, estimate the average speed of vehicles when the maximum flow is reached. The average speed at maximum flow is Uc equals to Uf over 2. We already have the value of Uf, and we can divide it by 2, and the value of our Uc is 35.91 km per hour.
Thank you.